I'm pretty sure this one right here. It's not a, it's not an easy question. Bro, stop giving me medium, man. No more medium, bro. Even this one. I feel so sleepy. This is the perfect time to do it. Okay, let's just so I just want to suplex people. I want to suplex. I do feel like understanding the major concepts and just moving on to the next one really productive. I don't know why. I just find that little bit more productive. Just my personal opinion. Let's do Pat. Pat's I didn't really understand it. How do I? Oh man, I need to make money. Fuck. I need to make a lot of money.
Hey everyone, welcome back. And let's write some
Yeah, that's fact. Jobs. It's very and like screaming a bitch. Reflect on. No, it's
More neat code today. So today let's solve the problem path sum. We are given the root of a binary tree and an integer, which is our target sum value, and we want to return true if there exists a root to leaf path. A root to leaf path is basically a path that starts at the root node of the tree and keeps going down until we reach a leaf node of the tree. And a leaf node is basically a tree or a node that does not have any children. So it doesn't have a left child and it does not have a right child. Now, this is a binary tree, but it's not a binary search tree, meaning that the order property is not valid, right? So this 8 node over here has a left child of 13. That left child is not less than 8, but it's still a left child because this is not a binary search tree, it's just a regular binary tree. So the fact that this is not a binary search tree means that we definitely have to go through every single node of the tree. We basically have to look at every possible root to leaf path in the entire tree and see if any of those paths ends up totaling the target sum value. So just to kind of emulate what we're going to be doing, we're going to start at the root, 5. So our sum so far is 5. We're going to go, let's just start at the left side. We could go right, but let's go left first because it's kind of natural. And then we get a 4. This is not a leaf node yet, so we keep going. Our total so far is 9. We're going to go left again. We are at 11. Now our total so far is 20. And by the way, our target is going to be 22. So this is still not a leaf node. Now we go left again. Now our total sum is 27. That's greater than 22. So this, even though we're at a leaf node now, this is not what we were looking for. So let's actually backtrack. Let's not choose this path. Let's not go to 7. Let's actually go to the other node, which will give us a total of 22, and that's exactly what we're looking for. So now we actually did find a single path that does equal the target sum, so we can definitely this one to the other leaf node. Neither of these paths ends up giving us the target value. So just by kind of looking at what I did, if you are familiar with binary trees, you can df reach one of them. Creating a helper function. The reason we're doing this is the example cases if the target.
Bro. Telling you, bro. Telling you, where is my code? What is the stretch my hand? Life like this is what the life like. Stretch my hand with you. Oh, but I do. I need a root current sum, and I need to, if not root, return false. Okay, that's I don't want to capitalize false, please. It's too much. You're asking too much of me. So I need to check. I need to go on the leaf node, so these extremes, and check if the, so that'll be, let's go self dot here. Probably not. Probably not. Let's take this thing. Let's put it here. And I just wanna fuck this little bitch up. Whoa. Current sum. What is current sum is gonna be? Maybe target? If it is, no, not target. It is current sum. I just wanna. Whoa, 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 whoa. Chill out, bro. Too much, sweat. Okay, if this, what is this? What even is? What even am I looking at? Okay, we have a root. This thing. Current sum. What is current sum? Is it like, should I like keep adding it on, or what's going on? Stretch my hand. Lifelike. This is what the lifelike. Okay.
Value from that node and add it to our current sum that we're keeping track of, and that's pretty easy to do. And the first thing we should check is now, intuitively, maybe we found the result, but how do we know if we did? Well, we have to make sure that this node is a leaf node. So basically, if not...
Bro, I know what to do, but my computer sucks. It's not even going to the next... Oh my god. Why is... This shit sucks. My computer sucks. I hate it. I want to throw it away. I think my mom bought it too. I feel sorry for her. Sorry, why? I hate it. Oh my god, please. Can I click something? So I need to add the current sum. It's going to be plus or equal to. Man, I'm so cringe. Root dot val. Okay. And I need to constantly change. Self dot. I want to kill. I want to kill myself. I want to kill myself. Kill myself. Yeah, let's just go node. Why not? I need to go node, comma, cur sum. I'm really that guy. And I need to, when the loop ends, and they find when they go to the top, or how do you just node dot left, I need to return fuck. What is going on in this? So, what is going on?
Not node.left and not node.right. So basically it doesn't have any children. And the last thing we're checking is, does the current sum equal the target sum? But we actually don't have to check this in a condition because we can actually do it just like this. If this is a leaf node, then we know we can't really run DFS on it anymore anyway. So we're going to return if the current sum is equal to the target sum. If it is equal, then we're going to be returning true. If it's not, a DFS also ends up returning the easiest way to both of these or them together, right? If either of these is true, then we can end up returning.
Bro, that's a really good way of looking at it. But I don't think it's like the most optimal though. So I could do this, or I could go if node left, if not, node left, node dot left, and not node dot right. Right. I need to return the Boolean value of target as a current sum. Cur I'm just gonna say cur is equal to target sum, and after all I need to return what do I need to return after everything is done? I think I need to return this. I mean obviously I saw what just happened, but I need to go DFS root dot left, comma target sum. This will kind of like do it for the left side. Why self? Should I do self? Stretch my hands. Lifelike. This is what the lifelike. People were to try. Okay, why node? Node what? It's not node though. What the fuck? And are you doing self? No, you're not doing self too. So what the hell? Instantiation is kinda gay. I'm pretty sure it's node. Did he like do something wrong?
Turning true. And that's actually the entire function. Now all we have to do is just call it. Let's call our DFS passing in the root node. And what should we pass in as the current sum? Initially, we can just say it's 0. And then we can return the result of this function. Now let's just run it to make.
That's so genius. Why didn't I think of that? So this goes here. I'm calling this one. Probably car. I mean, code doesn't really matter. Mia Khalifa, boy, hit or miss. I guess they never miss, huh? You got a boyfriend, I bet he doesn't kiss you. Okay, root. Comma. Target sum. Target sum is a big number. 0. Okay, I don't really understand it though. Yeah. Uh, 112. 112 path sum. One 12. I need money, bro. I need that. If these walls could talk, I just wanna know. Bro, why do people think of me? It's crazy. Some people message me saying they think of me and shit. It sounds schizophrenic, but it's true. Like, why? Like, I'm not that influential, am I? I will be, but people root for me, which is a weird feeling. A weird feeling when people root for you. Accept that, bro. This is fake. You're telling me 2 million people did this? That just like sounds fake. It's like I can't even believe that. 2 million sounds too high, bro. The best I can do is like 200,000 or something. 2 million seems too high. So what am I? It's false. It's true. What am I? Given a binary determined height balanced. If I could put this shit over here, it's balanced. If I put this shit, it's not balanced. What the fuck is height balanced, bro? What the fuck is height balanced? And why did I like look at this? It's I've tried solving it before, I guess. It's kind of. Why would I try to solve that?
Hey guys, Greg here. Let's solve balanced binary tree. LeetCode number
It is in here. Okay.
110. So we're given a binary tree and we need to determine if it is height balanced. And what that means is, well, a height balanced binary tree is a binary tree in which the depth of the two subtrees of every node node never differs by more than 1. Now that sounds kind of confusing, so let me show you an example. Okay, if we were given this tree, this actually is height balanced, so we'd want to return true for this. Now if it is height balanced, it means that its right height, which happens to be 1 here, and its left height, which is 2, the difference between its two heights, 2 minus 1, and we actually want the absolute value of that because we just care about the distance between those two things, that is equal to 1, and so that is at most 1. So as the definition said, as long as it's less than or equal to 1, then that means it's good to go. Okay, but we need to check more than that. We're not just talking about the root here. We need to make sure it's balanced everywhere. So the root might be balanced, but there might be an issue elsewhere. Let's check the other nodes. Well, if we look at this node, well, its left height is 1, its right height is also 1. The difference between those things is just 0, and that is also less than or equal to 1, so that is okay. If we were to look at any of these three nodes, well, all of their left and right heights are both 0, so all of those are going to be zeros. The difference between 0 and 0 is just 0, so all of those are balanced as well. So because all of these different nodes, all of the nodes in the tree are balanced, therefore the whole answer would be true. If we had a tree that looked like this, well, now if we look at the root here, the root would have a right height of 3 and the left height would be 4. So it's comparing 4 to 3. The difference between that is just 1. And so there's no problem in the root here. And there's actually no problem here either. That's comparing 1 to 2. That would be fine. But there is a problem if you're talking about this tree. So if you're rooted in this tree right here, if you're rooted in this, well, its left height is 1. Its right height is 3. And so just for this node here, the difference would be 2, which again is bigger than 1, and therefore since there is a problem somewhere in the tree, there is a problem overall, and so our total answer would be false. So we'll assume that it's balanced through this global variable, and we'll do our DFS here, and if we kind of ever find that, oh, here, there is actually an issue here, well, we would change this to be false here. And so that way, once we kind of came back from our DFS and we were done our helper function, after we are escaping this, we could check if we're balanced or not. If we ever turn it to false, our total answer should be false because there was a problem somewhere. Otherwise, if there wasn't an issue, well, then it just should be true like it was before. And so we can just kind of return the value of this global. Okay, so let's actually just assume that we are balanced, and you actually want this as the list of true. If you don't know why, I explained this thoroughly in the diameter of a binary tree video, but in general, you would want this to be a list when you're talking about a global variable, instead of like a local variable to the recursive function. Okay, then we're going to write a recursive helper function that's going to basically return the height of a tree. So it's going to return the height of a root. Now, if we don't have the root, well, then we want to return 0. Height is equal to the height on the root dot left, and we also need to get the right height, which is equal to the height of the root dot right. And now we can immediately say, hey, if the absolute value of the left height minus the right height, if that is ever bigger than 1, we need to do balanced anywhere, that means there is a problem overall, and our complete function here, this function should return false. So we set that to be false, and now there is always a problem. Now, if that is actually the case, we really don't care about the height of our function anymore, and so I'm just going to return 0, because if you've set the fact that there is an issue, well, then we know at some point we're going to end up returning false, and so we really don't care if our height thing is actually working at this point. It's already going to return false, so we'll just return the value of 0 in that case. Now, otherwise, if we haven't ran into an issue, well, then we just want our function to return the height. The height of our current node is going to be 1 plus the max of the left height and the right height. Okay, so this function is called height because it's returning the height of a root. That way you can get the left height and the right height, and you can measure to see if our current node is balanced. If it's not balanced, we ran into a...
Why are we maxing? I don't get it, bro. You're talking too much. You're talking too much. Don't really get... What are you trying to say? Diameter, should I do the... I'll try this again maybe. Same tree, I think I can do this. Okay, close my eyes, delete. Okay. we have like two trees. So if key is none, return true. Because it's I think it should be the same thing. Left and the right should be the same thing. I just don't. Yeah, no, don't do that. Can I? I sometimes feel like, what do my teachers think of me? Because like, I'm better off than some of them in a lot of ways. And yeah, they were some of them were kind of rude to me, some of them were nice to me. And yeah, like, what do I do? Like, what should be my reaction? Should I? What should I do, honestly? If it is not true, it should be false. And we're just gonna call. We already did call the thing, so let's give it a try. I think I need another line of code, I think. Why? A boolean. I should. Oh. I mean. Okay, this failed. That means it was equal. Oh. If it is equal. La 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 la. Na 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 na. And we have 1 2 3 1 2 3. Seems pretty. Obviously, this is true, and there used to be this. I don't know what is up with like women in teaching in general. They're just like so rude to you for no reason. I think it's like there's been like a study on female narcissism where they're just like more aggressive when you're a kid, you know? When they grow up, they're like, oh, nice meeting you, I guess. But when you were a kid, their whole demeanor is like different. It's crazy how it manifests sometimes. And I don't blame anyone. I'm not like a blamey type. But it is interesting. When you're like small and weak, they kind of like didn't give a fuck about you. Now they care about you? The fuck? Not. What's the difference between not? When if P not. I mean, it's the same thing, I guess. If I run this. So what's the return I'm doing now? Obviously the value. The value is the issue. They should work. Yeah, it's the same thing. P naught, P is not, it's the same thing. If P and Q, if both are, I mean, do I need it? Sometimes the P and Q isn't there. Okay. Yeah, I can see it. Some people, bro, they just. It is what it is, you know, like, it is what it is. Some people, like, don't really fuck with you like that. And can you really blame them? You are kind of an ass. I am kind of an ass sometimes. So, yeah. So, what is going on here? Yes, doing the check. It's returning. Okay, this and this and this and this and this and this and true. Okay. I get it when I see it, but it's like, will I get it the second time? That's the issue. La 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 la. Bro, can I get a please every time? This website kind of sucks. This website has some issues. I don't think he knows it. I want to see exactly where I'm at and what's the next thing to do. I don't want to scroll and second guess myself, please. The design is kind of shit. Let's try this one. I think. Bro, is this the one? No way. I mean, I think it's what I did. No way, bro. Bruh. I think this is the one that I did. I think. If not else if. Bro, I think I did this. No way. Did I do this? Bro, I think I did this. 110, bro. I think I did this. No way, bro. Am I that fucking. I'm so fucking cracked in the morning. No, I didn't do that. I didn't do it. I was contemplating. But I didn't actually do it. Would have been like sick though. So I'm taking the left tree and checking if the right is okay, or the same logic. That's it. They should work. Oh, obviously. This is my solution, at least. So yeah, that's actually like really smart. So what's the issue? No. What's the actual? Three brother. Let's look at the solution. It should be a DFS. Bro, I'm not doing a brute force. I'm not doing this shit. DFS. Give me a DFS. Python. Okay, if return true, comma 0, What do you mean, comma zero, bro? Just true or false, okay? Right is equal to DFS, okay? We're instantiating. What kind of DFS is this? Is this like a depth first search? The brute force solution wastes time by repeating the computation. We fix by that DFS returning two things at one node. The subtree is balanced. What the hell, bro? What the hell? I think this is the diameter of a binary tree. Diameter, bro, it's combinating left and right results. Is DFS that deep? Is DFS that deep though? I think it is. Let's copy this. Let's go here. Bro, DFS sometimes is like low-key deep like that. It's crazy, isn't it? Why is DFS deep? It should be like surface level at the best. But yeah, I think we lost some shit on translation. We're finding the breadth, diameter. So obviously it's like a breadth for search thing. Using DFS step-by-step algorithm, bro, doesn't even worst solution ever, worse than 100% solution in both. Okay, that's like a good way of like marketing, bro. Bro. This is bro, get the full screen up. This is beautiful. Oh my god. Bro, you get a for loop. Okay, this is like a function of, bro, while loop on a while loop. Bro, this is, oh my, what is this? Is this, it's from the math input, I think. Bro, this is some, bro. Oh, the best thing that I've seen. Oh my god, it's so funny. Bro. Bro, this low-key Sigmas. Brother, this is like pack it up. Pack it up, bro. Pack it up, it's over. You like, brother. Passing, let's look at it. I wanna see a depth for search, please. I don't want none of these like BFS. I think BFS is the best way to do it too. Diameter node, if not node, left node, right node, result is equal to max. What is this? I don't get, what is this? Results are .0, what is this? Initializing the build. It's like a 0. Return max plus 1, y is plus 1. Lovely day. Love leading, helper, root. Simply is in Python, okay. Okay, I think I'm done. I don't know what I